Okay. So, right now we're doing the PowerPoint AP challenge level question. A speeder passes a police car going 40 meters per second. It takes a police officer 5.5 seconds to carefully put down her coffee and start up the car. After that, she pursues with a constant acceleration of 15.5 meters per second squared. When and where do they meet? Okay. First things first is when I say copy a problem down, sometimes it's more useful to copy it in picture form than to actually write the words. Because physics is a very visual science. So what I would do is I would imagine this scenario. And here we have the cop car. And this speeder has passed the cop car. And it has taken the cop 5.5 seconds to begin the chase. So if you imagine the problem starting, the speeder is already down the road. I'm just going to call this S for speeder. So this is really what the problem looks like. The cop has an acceleration of 15.5 meters per second squared. The speeder has a constant velocity of 40 meters per second. And by the time the cop starts chasing, there is some initial distance between them, which will be important in a moment. Okay, go ahead and stop me if you have any questions as we move. The time that the speeder has for a head start is 5.5 seconds. And we're interested in when and where do they meet. So we're interested in the time that they meet and the distance or position that they meet. So again, when I say copy the problem down, this is what it looks like in my notes if I'm a student. It has all the essential information and the variables I'm looking for. Time at meeting, or when the cop catches a speeder, and the distance or position where they meet. So we have to set this problem up. We have two objects. Excuse me. We have two objects, so we're going to have two motion equations. The motion equation for the cop is going to be distance final cop equals distance initial cop plus VIT plus 1/2 AT squared. That is the distance formula, just in its totality. Well, we're assuming that the cop starts at the starting spot. So this goes away. That drops to 0. If the cop is parked there, what's the initial velocity of the cop? 0. So that term goes away too. So the position formula of the cop is really not that difficult. So the final position, I'm just going to call it C for cop, is really just 1/2 15.5 T squared. That's it. That's the whole formula for the cop. The position formula or distance formula for the speeder is slightly more complicated. In this case, the final position of the speeder, I'm just going to call that S, is the initial position of the speeder plus the initial velocity plus 1/2 AT squared, yada, yada, yada. Okay. So Nabil, is the speeder accelerating? No, he says, he's shaking his head. So this term drops to 0, because A is 0, so that everything else is 0. We do have to be careful because the speeder had a head start of 5.5 seconds, they have an initial position. We don't know what that is right off the top of our head, but they actually have an initial position. Let's figure that out real quick. What is this distance here? Well, for the speeder, they had, this is distance. They had a velocity of 40 and they had a 5.5 second head start. So they were able to go down the road, looks like 220 meters. So the position of the speeder is 220 plus 40t. That 40 is the initial velocity. Good so far? Okay. If we want to know when and where they meet, we better set these two things equal to each other because these are the position formulas. So let's set them equal and solve for time. That'll take care of the time. And if we know how long it takes before they meet, we can very quickly figure out where they are. So 1/2 of 15.5, I believe, is 7.75. So, well, maybe I shouldn't skip that step. Again, so what kind of a formula is this going to quickly turn into? Quadratic. So we deal with quadratics all the time. So we got to be comfortable with it. So this is going to be 7.75 t squared. I'm going to bring these terms over here because that's how we like to solve quads. Now it's in proper quad form. Where this is your A term, this is your B term, and this is your C term. You can't forget the negatives. All right, there are two ways to solve quads. One is to use a quadratic formula, opposite of v plus or minus the square root of all that stuff. And the other is to use technology, a quad solver. I would highly, highly recommend that you have a quad solver on your iPhone, your phone, your tablet, whatever you use, a computer, your website. Nobody should be hand cranking quadratic solutions in 2020. So you can always use quad solvers on tests, anything like that. Nobody should hand crank a quad. So at this point, you should have a quad solver ready to go. You're going to solve for A, B, and C. You can tell already you're going to get two roots. Well, you always get two roots. You can tell already that one root's going to be positive, one root's going to be negative. Since we're looking for time, you can disregard the negative root. It's meaningless for this problem because you can't have a negative time. So there's only going to be one positive root, and that's going to be our answer. Does anybody have a positive root? What do you got, Nabil?
8.50.
8.50, we'll call it 8.5. So t equals 8.5 seconds. Okay. That takes care of this. 8.05. Was it 8.5?
8.5 here.
Okay. 8.5 seconds is when they meet. Now we got our choice. We can put 8.5 into this formula here to get the position, or we can put 8.5 into this formula here to get the position. I would probably just put it into the, actually it doesn't really matter which one you do, it's just whatever's easier on a calculator for you. You're going to get the same answer whether you put it here or here because you have already set those two things equal. So does everybody have a position? We'll say 220 plus 40 times 8.5. That might be easier to do. So that's going to be 320 plus, so 340, so 560?
Yep.
Okay. They will meet 560 meters down the road from the initial position of the cop. So, again, whenever you're having two objects meet, you can set up the motion formulas or the position formulas for both objects, and they will be separate from each other. You got to be careful if there's a head start, because then there's going to be an initial position for this particular object, so you got to figure that out real quickly, kind of off to the side. Once you have their motion formulas or position formulas, you want to set them equal because you're interested in when they meet. In this problem, interested. And then once you do that, in many, many, many cases, it's going to be a quad. You got to be either real quick hand cranking a quad, which you shouldn't do, or just use technology to get you a quad. If it turns out you have two positive roots of your quadratic, it means that they meet twice. How could they meet twice? It could be a situation where they meet here, and then they meet again like that. But that would require an acceleration term here, which we don't have in this particular problem. So that's how we solve that AP level question. Stop my video.